Hello all, this is me, Ahmad, your professor. I'm trying to actually record some lectures at home, right? I don't have a studio to go to do professional videos for you. I'm using the tools that I have available here at home, like a small camera, a whiteboard, and some markers that I have. I don't know how the lighting will work here. I don't know how is the video or the audio in the video. I will try to make it kind of possible for you to can watch these videos and see the lectures. This is what I can do here for you, make some lectures. Also, as you are aware, soon I will send you an email that we will use Zoom conference. We have option the whiteboard option also in the Zoom conference. I will use that one also. I'll repeat the lecture, or maybe I'll answer the questions for you. The difficult part is that the days that we have class, like Monday, Wednesday, Friday, I will be from 9:15 to 10:30 on Zoom conference. But at this time, you are not kind of required to be in a Zoom conference, but same time, I'm encouraging you to come online, please, if you have kind of available internet at home, a computer, a webcam. You can see some lectures, you can ask me questions that you have about the lecture. I know I already received emails from you that because I post 2.7 on the Canvas, the PowerPoint, I know it's really difficult to learn from a presentation. It's really difficult for you maybe to learn something by reading the book. It's a math book. Again, it's not history to just read and memorize, it's math. And the presentation that I posted on Canvas, it's basically for teachers, not for students. There are some explanations, but not a lot of detail, because for our lecture we just need few points there and we follow our lecture. That's why one of the reasons that I'm trying to do this video for you, to check if this video works. Then I will record all the lectures every day before like 2.7, 2.8, and we move on to chapter 3 and hopefully chapter 4, 5. But I'm hoping that this problem that right now all of us we are facing, like COVID-19, will go away soon, and we can start back our face-to-face classes. Let's pray for that. But right now, the only tool is this video. Anyway, I'll try to right now explain to you 2.7. 2.7 is about derivatives. We are done with kind of limits. Now we have a good idea of what is limit. Using that idea, we will explain what is derivatives. Remember at the chapter 2, when we start with limits, I told you that the line, the tangent line is a line that intersects a curve in one point, right? If I draw here a curve for you, for example, this curve, and I have a point P here, the tangent line is the line that's touching this curve at this point. Let's name it, for example, P. And also, if you remember, I know it's a long time that we are away from the class, maybe you don't remember anymore, but I'm hoping. To find the slope for this tangent line, we actually use the secant line to find the slope for the tangent line. Remember? I will kind of show that idea again here, how to find the slope of the tangent line, then even how to write the equation for the tangent line to a curve in a given point. We will practice maybe one problem with that. Then slowly I will move and try to prove for you the main formula for derivatives. Remember that derivatives and rates of change, they are kind of same types of limits. They are a special types of limits because they have a lot of use in math, physics, maybe economy, other science subjects. Those types of special limits, they deserve a name. That's why they choose a name for them, which we call it derivatives. It means, again, right now in 2.7 you are dealing with types of limits, but soon in 2.8 I will give you formulas for the derivatives, and it gets easier. Let's start with the secant line. I'll draw here a secant line for you, and let's talk again about the slope of the tangent line. How to find the slope of the tangent line using the secant line, correct? To find the slope for any line, you need 2 points. I'll name this one Q, this one P. Let me draw that line for you. I don't know if you can see this red line or not because of the light here. This is the secant line that I draw. This point has, of course, point P has its coordinates. Let me name the coordinates of P, for example, on the A, on the x-axis. A is a number, right? If it's A, the coordinates on Y will be f of A. Let me name the coordinates of Q, for example here x. If it's x, on the Y I'll get f of x. Now, to find the slope for this line, for the secant line, easily I can write the slope of the secant line. Let's put here first secant. The slope of the secant line equals f of x minus f of a. It's like y2 minus y1, right? F of x minus f of a over x2 minus x1, which we name it here x minus a. That will be the slope of the secant line. But remember, I explained to you, to find the slope of the tangent line, if you bring Q closer to P, it means x coming closer to A. This was the idea of limit. I told you closer instead of saying closer as x approaching to A, right? As x approaching to A, Q is coming closer to P. It means it's not necessary, we discussed this, it's not necessary that Q should be equal to P, because if Q becomes equal to P, then I'll end up with 1 point and I'll end up with 0 over 0, not equal. Q cannot be equal to P, right? It means Q is not coming on the top of P, but it's coming really close to P. It means x is approaching to A. If it happens, it gives me the slope of the tangent line at the given point P. How to write that idea now based on the limit? I can write the slope of the tangent line, if I just name it m, the slope of the tangent line equals the limit of same thing, f of x minus f of a over x minus a as x approaching where? X approaching to A. That will be the main formula for you to find the slope of the tangent line. but they have to give you this point. For example, a can be 1, can 2, can 3, any point that they gives you. I'll do an example for you. If a is given to me, easily I can find the slope of the tangent line. And as soon as I have the slope of the tangent line, if they ask me, okay, now write the equation of the tangent line, the equation of the tangent line, even I don't need calculus, right? We already learned, okay, if I have a point and the slope, I'm using the point slope formula, and easily I can write the equation of the line. I'll do one example which is in your presentation that I sent to you. Example number 1, and I'll show you how to find the slope of the tangent line and how to write the equation of the tangent line if they give you a curve, correct? If they give you a curve and one point on the curve, you can find easily the tangent line. Let's do an example. I know you will see a lot of noises because I put the whiteboard on my office door. This is the only available wall that I have here. Kind of be patient. I know it's not a kind of professional video. I know it's maybe the quality is not good. Even today I download a kind of movie editor kind of software in my computer, but I know I'm not professional. I never studied those, right? I'll try to edit these videos, but for time being, at least what I saw in the emails, you need someone to explain it to you. What I'm trying is just to explain the topic to you, right? Anyway, let's do the example. Example number 1, find an equation of the tangent line to the parabola y equals x squared. At the point P, 1, 1. I want to write find the slope of the tangent line for this curve or this function. I can write y equal x squared or f of x equal x squared, at which point 1, 1. At least this is a very simple function, even we know the graph of it. Y equal x squared is a parabola, right? Like this. If I just draw one side of it, if this is 1, 1, 1 will be here, right? 1, 1. It means your A is equal to what? To 1. Now they're asking you to find the slope of the tangent line, the line that's passing from here. That will be the tangent line. They're asking you to find the slope for this line and also write the equation for this line. Now, step 1, I'm looking for the slope of the tangent line. Our formula was m equals limit f of x minus f of a over x minus a as x approaching to a. Now a is given. I know what is f of x. I can find easily the f of a, which is f of 1. I will plug those values here and it gives me the slope of the tangent line. Look, in the formula, the first thing that you have is f of x. What is f of x? Actually, your f of x is what? X squared. Then you can write m equals limit f of x is x squared, minus f of a. How much is a? F of 1. It means you are looking for the f of 1. If f of x is equal x squared, then f of 1 will be 1 squared, which gives you what? 1. That means here, x squared minus 1 over x, which I don't have the value of x, minus a is given 1. As x approaching to 1. Definitely here you cannot use direct substitution because you see 1 is not in the domain of this function. If I plug in 1 here, 1 minus 1 becomes 0, then denominator 0, it's a problem. Then what I do, I'll try to use the technique of algebra actually to simplify this, right? It's a rational function for me. We can factor the top, it's the difference of the squares, x squared minus 1, because instead of 1 you can write 1 squared. Then I will try to factor the top and try to simplify. Then this one equals limit as x approaching to 1. Difference of the square, x squared minus 1, we can factor it as x plus 1 times x minus 1 over x minus 1. Here, x minus 1 cancels out with x minus 1. It means we have a hole there, right? And let's now find the limit. M equals the limit of x plus 1 as x approaching to 1. Plug in the number, it will be 1 plus 1. It means what? 2. It means the slope of the tangent line is actually 2. The slope for this line is actually 2. Now, when you have this, the slope, it's really easy to write the equation. The next step of the problem, they are asking you to write the equation for this line. I have the slope, I have one point of the line, then using the point slope formula from algebra, I can easily write the equation of the tangent line. I'm erasing this really fast because I know this problem is in your presentation. You can see the steps there also. Just I'm trying to explain for you, right? Now I have the slope 2. I have one point of the line 1, 1, which is this one will be x1. This one is y1. I have the slope. The point slope formula, if you remember, it's y minus y1 equals m times x minus x1. Then y minus y1, 1, equals m. I have the value of m now, 2 times x minus x1, which is what? 1. Distribute 2. Y minus 1 equals 2x minus 2. Add 1 now to both sides. Then y equals 2x minus 1 will be the equation of this tangent line. It's kind of really interesting because you know you have the slope. This negative 1 is actually your y-intercept, right? Negative 1 is y-intercept. If you see, if you have here, for example, negative 1, and the slope is 2 over 1, if you move from negative 1 2 units up and 1 right, you see you can draw this line. And this line is passing from this point that's given to you, a equals 1. This is kind of review that we did before, how to find the slope of the tangent line and how to write the equation for a tangent line. Now, I'm trying to graph another curve for you. I'll bring a little bit of change in the slope formula, just the notation. The idea is totally the same, the notation. And we use that formula as a base formula for the derivatives. Actually, after I kind of prove it for you, you are not required to learn the proof. You will see a kind of formula that you used it before in pre-calculus and college algebra, and the name for that formula was difference quotient. Difference quotient is actually, if you add a little bit limit in it, it's actually the derivatives formula, the main formula for the derivatives of a function in a given point. After this example, let's do that one and move to how to, or what is the main formula for a derivative of a function in a given point. Again, I'll draw a curve for you. I'll change a little bit my notation. It means the name, but the idea is the same. and I prove for you the difference quotient formula. Again, let's, for example, this is a curve, really a bad curve. Let's do a nicer one, like this maybe. 1 point on the curve, and let's draw again the secant line. Let me choose another point here. This is the secant line. Now, what I do, I'll change a little bit my notation here. Just the notation, the names. The idea is, again, I'm looking for the slope of this line, correct? I'll name this point, for example, let me use black. I'm not sure if you can see green or not. I'll name this point A. And I have another point here. Before naming that point, let me show you. If I draw this triangle, if I name this, the distance between A and this point H, then if this point is A, this point will be A plus H. Right? For example, if it's 2 and this distance is 3, definitely this distance will be, the coordinates of this point will be 5, right? 2 plus 3, 5. A plus H. If it's A on the y-axis, I will have f of A here. If this point is A plus H, on the y-axis, I will have f of A plus H. Correct? Now, I will write the slope formula. The slope formula was m equals limit as x approaching to A f of x minus f of A over x minus A. Now your x is A plus H, right? Before I named here this part x, but right now I'm naming it A plus H. If I replace x with A plus H, and as x approaching to A, see what's happening in this formula. It will be m equals limit. Instead of f of x, I will write f of